In this video of coordinate geometry, we will be continuing our work with the gradient-intercept form. Remember the gradient-intercept form being y equals mx plus b, where m is your gradient and b is your y-intercept. In the last video, we looked at pulling bits of information and either creating this equation or pulling bits of information from this equation to get our gradient and y-intercept. In this lesson, we will be looking at what you can actually do with that information. So, let's go on. Graphing equations in the form of y equals mx plus b. As just mentioned, the gradient is the rise over the run, and the b is the y-intercept. So down the bottom here, we've got three separate equations, starting out with a nice and easy minus 3x plus 1, then moving into some fractions, and finally looking at an equation whereby we need to do a bit of work before we can actually use the information provided. So we'll treat each one separately and we'll look at how we can go about graphing it once we've pulled out the key bits of information. So here is our first one, y equals negative 3x plus 1. So the first bit of information we can pull out, possibly the easiest, is the y-intercept, and the y-intercept is simply just 1 because it is the plus b by itself. The next bit of information is the gradient, which is the coefficient of x, and the gradient in this case is equal to a negative 3. Now the first bit of information that we need to use is the y-intercept, because we know where the y-axis is, we know where all the numbers are on it, and at the moment our y-intercept is at 1, so we're going to put a big dot here at y equals 1. There is our first point. Then our gradient, which stands for rise over run, says minus 3, which in rise over run terms is it drops down 3 for every 1 it goes across. Remember, if you divide any number by 1, you still get that same number you started with. So we're going to start at our point here, our y-intercept point. We're going to drop 1, 2, 3, and then go across 1. And there is our next point. Once you have 2 points on a graph, all you simply do is draw a straight line between them, and that is your linear graph. So just a quick restep. We pulled out the y-intercept and we pulled out the gradient. First off, you graph the y-intercept, then you use your gradient to tell you where the next point is. In our case, we went down 3 and across 1, put a point there, drew a straight line between those 2 points, and there is our linear equation. Okay, moving on to a little harder example. We have y is equal to 3/4 of x and minus a 2. So the first and easiest bit of information to pull out is the y-intercept. Now in our case it's a minus 2, so our y-intercept is negative 2, simply because our formula says it should be a plus b. In our case it's a minus b, so that means to keep a plus in the middle there, we're adding on a negative number, so our y-intercept is a negative 2. The next most important bit of information is the coefficient of x being the gradient. So our m is equal to 3 divided by 4, and I'm just going to write rise over run here because that is how we go from our y-intercept to our next point on the graph. So our y-intercept is negative 2, so we're going to go to negative 2 on our graph, put a big dot there, and then we're going to use our gradient, our rise over run, to find the next point. So our gradient says a rise of 3, so we're going to go up 1, 2, 3, and then across 4. 1, 2, 3, 4. And over here is our next point. Then grab your ruler and rule a straight line between those 2 points. So I'm going to draw there and draw a straight line there, and there is your linear equation. Okay, moving on to the last example. Now, as I said when we first looked at this, it is not in the gradient-intercept form as it stands. We need to rearrange it so that it tells us the useful bit of information. So remember, what we're aiming for is y by itself. We can have anything in front of the x, and we can have a b, might not, because the y-intercept might be at 0. But that's what we need to find out. So in terms of our steps, we have a minus 3x and a plus 12 that all need to move over to the other side to leave the y by itself. So our first move with 6y minus 3x plus 12 all equaling nothing, I'm going to move my 3x over. It's take away 3x, so I'm going to move it over by adding it. 6y plus 12 is left on the left hand side, and that equals 3x on the right. Then I need to move my constant, my 12, across. So I'm left with 6y equals 3x minus 12. It is a plus 12 here, so to move it across I need to take it away. Then as my last step I have a 6, so I need to move the 6 across, and I'm going to do that by dividing by 6. So y is going to be equal to 3x minus 12 all divided by 6. Cleaning that up so it looks more like our gradient-intercept form, I'm going to have 3 over 6x minus 12 over 6. Again, cleaning up the fractions, I have a half x minus 2. So that final form down here is the most useful way I can write this information, because I can clearly see the gradient and the y-intercept I need to graph. So first off, my y-intercept is -2, so I put a big dot here at -2 on the y-axis, and then my gradient is a half, so that represents going up 1 and across 2, so a rise of 1 and a run of 2, and then rule a straight line between those 2 points gives you your graph. Straight line, and as straight a line as I can get. Doesn't really look like that, but you get the general idea. So that will finish us off with the gradient-intercept form of a line. We've looked at how to rearrange it so that it is in that form, and we have also looked at pulling out the useful bits of information, as the name suggests, being the gradient and the y-intercept. This example here leads us on to our next little topic, and that being the general form of an equation. Now, we're going to be introduced to a lot of different forms, especially for linear equations. All they simply are different ways of representing the same information. Some are neater, some are more useful, and other ones help us to get to the stage to be useful. So here, our gradient-intercept form is probably the most useful for reading information. The next one we're going to look at is the general form of a linear equation. This one isn't really useful at all. Sometimes it's more convenient to write, but it is definitely a very, very neat way of writing a linear equation. No fractions and no decimals, just nice whole numbers all on one side of an equation. So, the general form of an equation is written here. It is an ax plus a by plus a c all equaling 0. The important bits of information to note are that a, b and c are integers, meaning they're whole numbers only, and that a has to be positive. So we're not worrying about the y in this case, we're worrying about a positive x coefficient. So let's have a look at what we need to do to make it look like general form. Here we've got a few equations. The first one, y equals 6x plus 2. We're asked to write all these in general form. Now personally, I'd probably leave it like that. As I said, it's a much more useful way of writing a linear equation, and they're all whole numbers anyway, so it just seems like extra work to convert it to general form, but you need to know how to do it. So we need to keep step 1, x must be positive. That is what we need. And step 2 means all coefficients have to be whole numbers. They're the two steps we're working towards, x being positive and all coefficients being whole numbers. So our first example, we look at our x. X is already positive, which means we leave it where it is. We move everything else to join the x. In our case, our y needs to come across and join x. The way we're going to get rid of a y is to take it away. So if we minus a y from a side that only has y on it, we're left with nothing, equals 6x plus 2 minus y. Now rearranging that to make it look like our general form, remember general form being ax plus by plus c equals 0. So at the moment we have our ax, which is 6x Then we need to add on, next comes the y, so we have minus y plus 2 equals 0. And there is our general form. And that's all there is to it. This is just simple algebraic transposing an equation, moving things from left to right or right to left. Okay, looking at example B, we have the first step being to make x positive, and at the moment x is negative. So we know we're going to have to move x across the equal sign so that we make it a positive one. Because that's the way we get rid of a negative number, is to add it. So y plus 2/3 x equals a 2. Then we need it all to equal 0. So to get rid of the 2 and move it across, we need to take it away. So we're left with y plus 2/3 x minus 2 equals 0. Now, that's almost in general form, but remember, the second part of general form states that both a and b and c are all integers. That is, they're all whole numbers, not fractions like what we've got. So what we need to do is get rid of our 2/3 and turn it into a whole number. And the easiest way of doing that is to multiply every term by the denominator. So our denominator being 3, that is the fastest, easiest way of getting rid of divide 3 is to multiply by 3. So we're going to have 3y plus 2x minus 6 equals, anything times 0 is still 0. That's where the benefit comes in of rearranging it first to be equal 0, is that we don't have to worry about multiplying that over there. Then to make it even more like general form, x comes first, so 2x plus 3y minus 6 all equals 0. And there's our general form. Okay, last example, much like the one we've just done, there is a fraction involved, so we know we're going to need to get rid of that come near the end of our working out. But first, it's easier to move everything onto the one side where it should be, so that we have a 0 on one of the side of the equal sign. Our x is already positive, which means we're going to need to move our y to join our x, and we're going to do that by taking it away. So we're going to be left with 0 equals 2x minus 3/5 minus y. Now, it's looking pretty good at the moment. All we could really do is switch the 3/5 and the y around to make it even more like general form. But we have a fraction, we have a divide 5, so we're going to need to times everything by a 5. So we're going to have on our left hand side 0 times 5 being 0. 2x times 5 is 10x's minus a 3 minus 5y. Then we can simply rearrange that so that it looks even more like general form. 10x minus 5y minus 3, and we're done. Okay, that's it between converting from gradient intercept form to general form. And we'll move on, have a look at a couple more examples so that we're prepared for all that we need to be prepared for. Alright, in our case we've got our general form, so we need to convert them to gradient intercept form so that we can pull out the key bits of information. Okay, 2x plus y plus 5 equals 0. We need y by itself, so the form we're going for now is y equals mx plus b. That is our gradient intercept form. That's how we're going to calculate the gradient and the y-intercept. At the moment these are all written in kind of general form except for example B there, so we need to do some rearranging. Alright, as it states, y needs to be on its own, so we need to move the 2x across and the 5x across, and we're going to do that by taking away both of them. So y equals, we took away the 2x and we took away a 5, doing both steps here in one. I think you guys can handle that, and that's about it. So pulling out our key bits of information, we need a gradient, and that's simply the coefficient of x being -2, and we need a y-intercept, that being the number on its own of -5. Okay, next example, we need y to be positive and on its own. At the moment y is negative, so we're going to move it to the other side of the equation. So we're going to be left with 8x equals 10 plus 2y. Now to make y by itself, we're going to need to get rid of the 10 by taking it away. 8x minus 10 leaves you with 2y. Then, to get y by itself, we need to move times 2 across by dividing by 2 on both sides. So we're going to be left with 4x minus 5 equals y. I could swap it around and put y on the left and x's and stuff on the right, but this is good enough. This tells me all the bits of information I need. The coefficient of x is 4, so the gradient is equal to 4. There is a minus 5 by itself, so I know the y-intercept is equal to minus 5. In our last example, just very quickly, we need to move the 4 across and an x across. They're both positive, so we're going to minus those each. That'll leave us with a positive y value. We're going to be left with 2y equals negative x minus 4. Now we need to move this 2 across. We're going to do that by dividing. So y is equal to negative a half of x minus half of negative 4 is negative 2. There are my key bits of information. The first one being the gradient, m is equal to negative a half. And the second bit of information is the y-intercept, and that is the number on its own, and in our case is negative 2. So there we have quick rearranging of an equation so that we can get it from general form into our useful gradient-intercept form, and we pulled out the bits of information we need. Maybe the question from here would go on to say graph the following lines by plotting the y-intercept and a gradient, but that's it for now. Okay, thank you for watching this video and good luck.